Chapter 28, Steering Systems and Integral Steering Gears, Day 1, Video 3, Steering Gears. We're going to touch real quickly here on steering gears. I've got in later days lectures a little bit more in depth on the steering gears. But I wanted to talk a little bit about the manual steering gears and power steering gears that we've got. So that rotational force that the driver puts into the steering system is we take that into the steering gear, and then that's where it has the gear multiplication, or the increasing of the effort from the driver to multiply his strength or multiply the steering effort to get from the driver. We've got a manual steering gear, which means absolutely no power assist, but just the mechanical advantage that happens from that, the gearing reduction that's inside of the steering gear to improve or to increase the operator's steering effort that puts him into the rest of the system. By far the most common would be our power assisted steering gears. We can have a hydraulic system where we use hydraulic oil to assist that steering gear to power the steering system and increase the effort from the driver. Manual steering or manual recirculating ball steering gear, power recirculating ball is by far the most common. And then a little bit least common is the power rack and pinion steering. So the gear reduction that is built into the steering gear, we can have a high ratio or a low ratio. Advantage of the high ratio is we got lots of multiplication of the driver's effort, but that comes at a cost of more turns of the steering wheel are required to make those turns. So it's a high ratio. Low ratio means it takes less turns of the steering wheel for the steering to turn from lock to lock. So that allows very quick movements of the steering system, and then little input from the steering wheel. Less steering wheel movement, and we get a quick movement of the truck in and out of lanes, changing lanes. So that's the low ratio. Touching real quick on the power rack and pinion steering. So a completely different system here. So looking at our power rack and pinion here, we've got the steering gear, the steering shaft from the steering wheel coming all the way down right into the rack and pinion. So we've got a spur gear that will act on the hydraulic rod going through the middle of that rack and pinion, and it's got teeth cut into it so that spur gear engages those teeth, and as we turn it right or left, this hydraulic, the rack, will come more out this side of the housing here, and forcing this tie rod end to turn the steering wheel this way, or turn the steer tire this way, and pulling the other one that direction, back and forth to initiate the changes here. A little bit better diagram of that. Again, here's the steering column. Steering shaft will be hooked up here, the steering wheel, and taking that effort right into that rack and pinion. And then here's the tie rod ends that would move further out this way or in as we are turning the steering wheel, causing that pinion to act into the rack, pulling it or pushing it one side to the other. Advantage to the rack and pinion is that we've eliminated a lot of components. We've eliminated the steering gear, so a lot of those components are combined. Steering gear, steering linkages, a lot of them are combined into one unit. So there's less moving parts, more ability to save on costs, And that, one of the problems we have with over-the-road trucks is Class 8, 6 through 8 trucks is the amount of effort that it takes does not lend itself well to the power rack and pinion system. We had lots of failures in that system, but there are still some out there. Again, the advantage was replacing a lot of those components. They were built into the one unit, the rack and pinion. So again, weight savings and then fewer components in the steering system.